our research and our take on digitalization, meetings in the circular economy, and how these two concepts interact to the benefit of companies and the society. I present some of our research in the context of business-to-business industries, and I'm happy, to spend roughly the next 40 minutes to give you some insights into those research results. Basically, I present research going back to my doctorate student, Andres Alcayaga, who also logged into the meeting. So maybe we have the opportunity to involve him also in the discussion. And so, the full team engaged in this research project is on board today. So, maybe before I start into the actual topic, maybe just to introduce myself, I'm leading this Institute for Integrated Quality Design at Johannes Kepler University in Austria. And we are a small research team of dedicated researchers entirely focused on the circular economy. Circular innovation and quality is actually our motto, and it is informed by three important conceptual perspectives: circular products and services, or the product life cycle, if you will. So of course, we have been informed by also the Ellen MacArthur Foundation Butterfly Framework. The other dimension which interacts with our research is innovation, innovation in product, innovation in business models. And the third important dimension is actually management systems, certifications, and standards, like, for example, new circular product standard, like cradle to cradle certified. So we look particularly how this can be communicated, these new properties of circularity, to customers as well using certification. We are based in Linz, in a beautiful town between Vienna and Salzburg, which you probably better know. And it's an industrial powerhouse, and basically large parts of the industrial production in Austria is in this state in around Linz. And therefore, there's very interesting research opportunities with this industry. And of course, that was also this context in which our research on digitalization took place and where we benefited a lot from. So maybe the one or the other practitioners on board today as well, and I just want to finally to introduce our institute, show our claim as well, or our motivation to actually bridge research excellence and practice impact. So we're, I think, good in academic publishing, which is expected of academic institutes, but we are also partnering very strongly and strategically with many businesses, particularly from industry, manufacturing industries. And this was, of course, helping our research approach into this topic. But let's get started. What actually is a topic? Digitalization meets sustainability. This is two huge buzzwords, actually. And of course, we have to break this down, this broad and generic title, into our specific interest and hopefully also your interest. So this is an old slide, basically, which I used 2015 and onwards. But that was a motivation once we started. I think 2015, 2016, we started to think about this topic. And it was a time where it became clear that more and more products and devices and objects get connected to the internet, what was then called the Internet of Things. So everything gets connected, and there's an exponential growth. And I think today we're living in a world where this has happened already, and it's quite normal to us that things are connected. We can differentiate, and for research that I present, it's important that we look into actually the industrial Internet of Things rather than like the consumer Internet of Things. So we are less interested in how consumers connect their smartphones with their personal household and maybe some automation in their household, but rather in how industrial firms equip products with digital intelligence in order to provide circular services. So we got actually inspired very much by this 2016 report of the famous Ellen MacArthur Foundation, and they published this intelligent asset report, unlocking the circular economy, and they claimed that the Internet of Things and therefore intelligent assets and machines, products will be a major driver to the way we make, use, and reuse stuff. So basically how to deploy circular strategies like remanufacturing, repair, reusing, maintaining products, etc. I want to introduce this idea and ground it a bit more by using one of our industry examples, basically from our study. So SKF is a component manufacturer, not far from our university. It's basically a Swedish company headquartered in Sweden, but there is a major plant here in Austria nearby the university, and they also have the global responsibility for remanufacturing processes. So they produce bearings, which is basically used in any kind of application where you have some form of rotation, for example, a wind turbine, but also many other machines. In the private household, you may know roller bearings from a skateboard, for example, or inline skates in a tiny variant. But these are more industrial applications here. And the idea, what they are driving is that they don't want to sell new products, new bearings, but they really want to reuse the old bearings and actually remanufacture them. So that's how an old bearing, a used bearing, comes back to them, and on their remanufacturing side, it looks very dirty. It is used. It is sometimes damaged, and from that they produce a beautiful remanufactured device in so-called quality as new. So everything is um, disassembled and basically brought back to a quality as new before it is redelivered to the customer. And the advantage of this is that you have a really tremendous, much more radical environmental impact, about minus 60% resource efficiencies and less energy. So that goes much beyond the usual, let's say, incremental efficiency gains which you have in other environmental strategies. So that is a very interesting strategy, remanufacturing for machines and components. I don't want to go into the process so much, but now the smart assets or the intelligent assets, the digitalization comes into play here, because it is actually quite difficult to convince customers to bring back these devices, these bearings, and to bring them back at the right point of time. And if you look at how SKF improved that kind of relationship with their customers, you can see that they deployed digital devices, sensors into their bearings and created an infrastructure to be able to monitor those bearings at the customer side. And you can see here a normal development or deterioration level of those bearings over time. So down here you see the service time, and up here you see the diminishing quality measured by the vibration level. So if you have a clear rotation, a smooth rotation, the product is still new, but when it gets older, you have more vibration in the rotation, and that is bad for the product and bad for the effectiveness of the, for example, production processes where those components are used in. So usually you have this kind of curve here. You have some damage starting, some vibration starting. It gets more, the vibration gets stronger and stronger, and usually customers wait until the product fails and then call SKF what to do, but that's far too late. And on that, if you wait until very late, then remanufacturing of the component is not possible anymore. The costs would be much too high. Sometimes it's technically not possible anymore. And so the remanufacturing likelihood is very, very low. So the idea of SKF was how could they make customers bring the components, these bearings, back early enough, so bring this curve down here so that the remanufacturing likelihood is very high, and because the costs are very low to remanufacture. And that's where the intelligent assets come into play. So this condition monitoring based on digital sensors and basically the connection to the Internet of Things helps them to identify the very earliest moment where those products have to be brought back and to be remanufactured. Then they can communicate with the customer and tell them about this need, and then deal with them with regard to the costs of replacing those products by reused components remanufactured in a quality as new. So the idea is here, you can see here that digitalization can have the potential to actually enable circular strategies like repair, remanufacturing, maintenance, and it can help to implement them in a more effective way than before. So that was kind of the motivation why we wanted to look deeper into this field and how digitalization links into the circular economy. So let's we talked a lot now already about circular economy and digitalization, but let's have a brief look into some core concepts that we still need probably to understand our core results. First of all, this is a complicated chart, but we wanted to define first what is actually coming from those intelligent assets, what is actually what we call a smart product. We called it a smart product in the Internet of Things. So for example, the bearing with the digital sensors is a smart product. And if you look at, we basically differentiated more simple products like a t-shirt maybe, or a textile, and more complex products like these components that you've just seen, or entire machines or vehicles with many components. But in a simple product, basically the smartness, you have the traditional component of the product, like in a textile, you have the actual textile, and you usually add to make it smart. You usually add some minor component to connect it to the Internet of Things, like a barcode or an RFID tag, so that enables it to communicate in some form with digital infrastructure. But the infrastructure, you also, next to the smart product, you need some form of infrastructure provided by the producer or actual service provider. And so you have a whole communication between a smart product, which is the traditional components plus the digital components, can be software or hardware, with the infrastructure. And additionally, we have some firm-centric infrastructure. For example, the producer has some servers which connect them to those products, but you may also have some customer-centric infrastructure. For example, measuring points or identification points at the customer side, because there usually data has to be collected, of these maybe locations have to be tracked where these smart products are at the customer side. And so you have a distributed infrastructure at the customer side and at the producer side. So three components: producer side infrastructure, customer side infrastructure, and the actual smart product. And these three things come together to enable what we call as a smart product in the Internet of Things. In complex products like those machines, it looks a little bit different because you usually have larger IT components, hardware and software within the product. So maybe you need even less infrastructure at the customer or producer side because you have more intelligence built in the product. For example, machines, of course, have entire maybe smartphone-like capability rather than just a tech in a textile. So we talked a lot about the circular economy already, and circular economy has been hot for the past 10 years at least. And I think one originator of this concept and who popularized it is Walter Stahel, who published also a very nice article in Nature about the different so-called technical cycles in the circular economy. And basically, that's what we are dealing with in our research, and in this particular research on digitalization, we now look into these different ways of reusing materials and products. And I just showed you remanufacturing at SKF as one exemplary strategy, but there are different technical cycles which are relevant, which we looked at. So of course we have the material cycle, the outer one, which is basically about recycling. To my opinion, we talk too much about recycling because, as Walter Stahl has said already back in the 90s, recycling is the strategy of less value and less environmental benefit. And the other strategies is called slowing loops, if you will, like remanufacturing or reusing and repairing products is the much more valuable strategy from a business point of view, but also from the point of view of the environmental value. So today as well, I will talk in particular about these slowing strategies and prioritize that in the presentation. So with the Internet of Things, with the intelligent assets, you need, as I just showed you, you need those smart products and certain infrastructures. So taking this framework by Walter Stahl here, you basically need to conduct all these, or to improve those circular strategies from recycling to reusing. You need the intelligence in the actual product circulating here, but you also need certain intelligent infrastructure to communicate with those products. You can then see that there are different ways to engage with digitalization in the circular economy at different stages here in these cycles, value cycles, if you will. And we've already seen some of those practices in the example. So for example, here in the beginning, you need some condition monitoring. You need some location tracking maybe to get those, to improve how to get the products back. You can do preventative maintenance instead of traditional maintenance. And you can also, to inform innovation and product redesign, you can use the data to actually feed this back to research and development and improve the products. So there are many ways of using the digitalization. And a side effect, or I would say a side effect of this kind of digitalization of the assets is that it leads actually to more intensive service perspective on how industry works, because basically digitalization is you need digital services to make that happen. And of course, the circular economy itself, these circles here can also be considered as services because you're taking back of product, maintaining product, repairing products is, of course, not the original production activity, but rather the after-sales service activity. So both digitalization and circularity leads to services, and it leads to a focus on servitized business models. And that's the last component in our research. So we root our thinking a lot in this classic paper by Arnold Tucker, who differentiated different service business models from more product-oriented business models. For example, if you just have an add-on maintenance contract on top of the product sales, and that's a more product-oriented service. And use and result-oriented services with a higher degree of servitization, where you actually sell the use of a product, like in car sharing, rather than selling the product and the ownership. So we have a tendency towards higher degrees of servitization when deploying digitalization and circularity. And we particularly in the study results that I present now, we look at the very operational level, actually, into these service business models. So if I may relate to some of those business model typologies, you can look at, many of us look at the kind of Osterwalder framework in the business model sphere and look at how the total business model works with all their components. But what we look at is actually the lowest level of a business model and look at the actual activities within those business model frameworks and components. And we actually looked into the industry, which kind of digital circular activities they deployed. So that leads us to our to the core of my presentation today, to the smart circularity framework, which is already has been published 2025 in the R&D Management Journal, and informs, I think, research and industrial practice at the same time. And for those of you doing research yourself, just want to have a quick longitudinal perspective on our publication process, because of course things usually take a lot of time, and we started actually in 2019 with some conceptual work around this linkage between digitalization and circular economy, published this in a Journal of Cleaner Production, and then started the empirical work in the business-to-business industry in Austria and broader German-speaking area. And the first ideas and preliminary results were published actually in an industry white paper with Quality Austria in 2020, and we also brought this framework into the German National Circular Economy Initiative. So these kind of industry and practitioner outlets were much faster than our actual research in academic journals. We published a working paper basically with the entirety of our research results in 2022 on our institute's website, and then it took additional years to actually get the framework, the core of what I now present, published in an excellent academic journal. So the academia works very slow, but so we are happy to be able to present this to you today, this core framework. Before doing that, just one more insight into into the basis of our information and of our framework building. We actually had interviews and collected publicly available documents and observed companies in the German-speaking area, particularly in Austria, nearby the university, and the industry here. And we have a big focus on business-to-business manufacturing industries. Basically, 62% of our sample is in this industry. We added some academic research institutes with experts in this field, and some service organizations, and also some IT companies also active in this area. But the main focus is actually manufacturing industry. Our core understanding of how digitalization and circular economy comes together can be explained in this beautiful framework with many components, of course, and I try to walk you through our thinking here. We call this, as I told you, we looked at servitized business models, and we consider this whole thing a smart circular system, and it is basically composed of these different circular strategies which I presented before, like smart maintenance repair, smart reuse, smart remanufacturing, and smart recycling. So this is certainly the core of our framework. Let me try to get a better laser pointer here. But we actually extended this usual treatment of these circular slowing strategies. We found out that by talking to the companies, it actually starts earlier. They don't really start digitalization to become circular, but they actually start digitalization because they want to better understand the use phase. So we started with smart use. They want to better know how customers use their products. And so we have two blue strategies here, one cross-cutting strategy, we call it smart cross strategy because it actually enables the other strategies like smart use and smart circular strategies like maintenance, reuse, remanufacturing, and recycling. So we have these different layers. And we have, of course, certain actors which are key in those relationships. We have the producer and ecosystem partners, as we call them today. And we have the customers, and between them is the smart product. As we heard before, there's some infrastructure. It's not included here in this imagery, but there's some infrastructure so that producers and ecosystem partners can communicate with these smart products at the customer side or wherever they are. And the idea is now that the data from these smart products enables and actually increases the effectiveness of these different smart circular strategies. These are those arrows here. And the other arrows is actually because it's more like we consider it like an iterative process. Like once these smart strategies are conducted by companies, they can learn from them and provide the data they generate from those activities back into their R&D departments or into their procurement for new products to change the product design to become more a circular design, and then to improve those strategies in a subsequent iteration. So that's kind of the iterative modeling here, what we think what happens when industry deploys intelligent assets for circularity. And we saw some trends or some general relationships with our companies that we studied. So first of all, we saw that these that's why it's a funnel form. So we use the reversed pyramid, sort of funnel form. So basically, companies usually start with smart use, and then it kind of trickles down to the other strategies. So they start thinking about how to better maintain the product. Then later they try to maybe get the product back and try to get it reused in a secondary market or remanufacture it. And if that's not possible anymore, they recycle it. So the frequency of transactions, of data transactions of these intelligent assets is reduced by going down here, because certainly the use of the product is more frequent than, for example, the recycling at the end of life. I think that's natural in a way. As I said before, these slowing strategies are usually considered more environmentally of higher environmental benefit than just recycling materials. So that's the environmental value in this hierarchy. And last but not least, we also saw that companies actually are on a learning pathway. So yeah, they start using digitalization for better getting transparency in the use phase, and later they actually started then to engage in the circular strategy. So that's a kind of a um, stepwise approach, if you will. So that's the overarching framework, and so the considering all activities together, that's actually the activity system. We have these activity sets in the business model, for example, smart reuse, and we have these individual activities which we found out, and I will show some examples now in each of these categories. So let's go inside. For example, let's start with smart use. I already told you that companies were motivated usually to better understand the customer because that was often a black box. So they used digitalization, like this Rubble Master company here close to Linz, a very successful machine builder for recycling machines in the construction industry. And they, with the digitalization approach and the smart product approach, they were able to provide their customers with these handhelds where they could actually monitor the machine, configure the machine in real time, derive statistics, and also get into touch with the producer, for example. So that's, I think, in most cases, the motivation to invest in digitalization. Very few companies, I think only the absolutely intrinsically motivated companies said that they really want to use digitalization in the first place to drive circularity. So that's better understanding the use phase. And based on that, usually companies then found out that they could use the digital assets in much more advanced forms. So going into this category or into this activity set of smart maintenance and repair, we found out that companies actually use the smart assets to better coordinate preventative maintenance. So before actually something happens, and also in remote places to monitor those assets and have a preventative approach to facilitate also do-it-yourself activities by the customers. And to more quickly identify, for example, spare part requirements for future repair activities. Just to give an example, Engel company is also a big machine producer here in the area, and they developed from a more traditional maintenance approach. They produce injection molding machines for the plastic industry. So you use these machines to produce bottles, for example, and or any plastic forms. And they came from the more a traditional maintenance approach and then digitalized those machines and now operate more in a predictive way so that they really have in the best case, a real-time understanding of the actual machine condition, or at least if these machines are not connected in real time to the producer, then at least the machine collects data, and when the service personnel gets to the customer where the machines are positioned, then they can actually get the data out of some local storage in the machine and better understand what happened to the machine and what was maybe wrong use of the machine and where's trouble, where needs to do some, where maintenance needs to be done. So this avoids this kind of predictive maintenance and avoids unplanned downtime and allows better planning both for customers and for the producer in providing maintenance and later also repair activities. So usually, of course, customers are provided with kind of a dashboard, and also at the producer side, they have like monitoring softwares where they are able to engage with these intelligent machines then. Going further down the road, after the maintenance, we looked into smart reuse, of course, because once the customer has no need anymore for their product, and maybe wants to give this to a second market or returns it to the original producer so that they can handle it. The question is, yeah, how can reuse be done and improved by smartness or those intelligent assets? And here we actually look not into the machine building industry, but we'll also have industry examples here for more fast cycling goods, textiles, also in the business-to-business industry, not the consumer industry. We actually looked also into one company doing rental textiles for different industries, for example, renting out surgery textile surgery clothes for the doctors in the hospital, for example. And this industry has very high quality needs because the clothing, the jackets and the trousers, etc., everything that the doctors wear has to be very clean, has to be certified in a way that there's no bacteria, etc. So they use most of the time today single-use clothing is used, but they provide the rental clothing and provide hospitals and other industries with certified hygienic clothing. They bring the clothes to the hospital and take it back, clean it, and to improve this process and to enable and make this reuse of textiles and clothing more efficient, they use digitalization. They put RFID tags into those clothings, and in a book chapter we delved a bit deeper into this case study. If you're interested here, the citation is here, so you can see here the whole process. From we distinguish between a clean side where the clothing are clean and the dirty side once they are used. So what happens is that basically in the beginning the company delivers the rental textiles to the hospital. There is some infrastructure to measure the numbers of textiles in the storage. So once there are not enough clothings anymore, then there is a signal sent to the producer or to the service provider to bring more clothing. Then they use it in the hospital, and the dirty clothes are retrieved, brought back to the facility, and there's all kinds of measurements and tracking where those textiles are and what their condition is. And in this, they are washed and then go to the clean side again. And they use all kind of this digital information then to inform the customer about the availability of clothing, about the kind of use of clothing, about the misuse of clothing, about missing items. Maybe there's some theft going on or things are left elsewhere. And so there's a very good reporting about these intelligent assets and also some reporting, for example, back to the customer, how they could improve this thing to save cost and improve the processes. So that's a very strong customer relationship based on this digitalization. The customer relationship has intensified a lot. They are a lot in communication, and that, of course, improves also the business with these customers. So digitalization can not only improve complaint management, as we have here. We derived some statistic from that business case as well. So what happened is that over the time they deployed those digital assets, that the business actually improved, and the doctors and the other people using the clothing were more satisfied with the service. So that's one thing, but in general we can say that there's a much stronger relationship, and rather in contrast to transactional sales where you just sell the ownership, in this rental business model you have an intensive customer relationship, and digital assets improve that. Yeah, going down further the line here into the smart remanufacturing strategy, I actually presented that in the beginning as a motivation. So the SKF example of digitally monitoring those bearings, and we already saw there how this intelligent monitoring improved the remanufacturing strategy and actually made it successful in the first place, because waiting too long makes it unavailable, makes it impossible. And interesting here to go one step further, maybe here is also to stick to this example, is that they use a digitalization not only to drive the remanufacturing and make it more effective, but also to further servitize their business model. So they introduced a couple of years ago their performance-based service business model, which they called Rotation for Life. And basically, they do not sell in this business model, they do not sell the bearing, but they sell the performance of the bearing. And this is only possible because they could actually measure what is going on at the customer side and how the product performs. And using these performance indicators, they provide a high reliability of the component to the customer to a fixed monthly cost. So digitalization enables them to move from transactional sales of the component to actually service-based business model, selling the reliability or the performance of their components, and also to make remanufacturing a core of that business model, because the customer, if you sell reliability, the customer doesn't want ownership of the product anymore, but they only want reliability, and that means you can also deliver a remanufactured bearing as long as it's as reliable as the new product. That doesn't matter to the customer. And here you see how digitalization, remanufacturing, and the service business model come together to drive change in the traditional relationships between industrial producers and their customers. Smart recycling was actually not so heavily covered in our sample and in our study. And as I said, I will focus anyways more on these upper slowing loops. And hence I'll go ahead here. Maybe one note here, we saw, of course, that by driving these intelligent assets and incentivizing smart maintenance, smart reuse, and smart remanufacturing, that these companies were successful in actually returning the products based on these intelligent assets. And of course, once these products are back and they felt there's no sense anymore in maintaining, repairing, or remanufacturing those goods, then of course those products were disassembled and brought to a recycling process. So that's pretty much a no-brainer. Okay, so I walked through these different categories of the framework, and I think important is not only these individual categories, but beyond that, it is also the combination of those categories. But first of all, we concluded from this study that this digitalization in the form of intelligent assets is really can be an entry point for circular strategies. It doesn't have to be, but it can be. And usually companies develop from a more like smart use type of monitoring products to these smart circular strategies. It is the digitalization particularly enables these slowing loops, which are also in the priority regarding the environmental impact. It also helps to do smart recycling, but particularly difficult are slowing loops, and these can be made more effective with digitalization. The servitization of the business models is, I think, a consequence of marrying digitalization with circularity. Both to actually make digitalization happen, you need digital services. So it's a service approach per definition. But of course, also all these circular activities, bringing back products, maintaining products, repairing those, it's all in the service sphere and not in the original production sphere. So servitization is a key concept and a key trend, I would say, has been for a longer time, but both these trends, digitalization and circularity, increases this trend. We have a high degree of servitization in many of those leading companies, because that enables the companies to interconnect these different strategies. And to really provide a full circular offering, incorporating maintenance and repair and take back and recycling, for example. So it's not only about individual strategies, but it's about interconnecting them for a full service offering, holistic offering, and delivering that to the customer. Our study, one main limitation is that we look into the opportunities here of digitalization, what we didn't look at, and I think particularly in the consumer sphere, in the consumer intelligent assets, that's a huge problem. Of course, many of those negative consequences could also be looked into, for example, shorter product lives because there's no new software update or something like this. So digitalization, of course, also has many negative implications, but we focused here on the opportunities. Yeah. To finish it up, if you're interested in this kind of activity and research, and particularly in this topic of digitalization and circularity and sustainability, I invite you, maybe some of you come to the Academy of Management conference in Copenhagen this summer. We have a symposium here where I also hold a presentation and a couple of colleagues on this topic. If you're interested in the broader circularity space and sustainability innovation space, I also recommend you to join also at the Academy of Management, our Towards Real Utopia professional development workshop, which will be fascinating, I guess. And beyond that, I invite you any year. Now we have the European Management Conference in June in Florence, but every year we are offering, and I'm heading this track on innovation for sustainability, circularity, and green technologies with many colleagues from across Europe, leading colleagues. And of course, we're happy to see your papers being submitted and discussed with us on site at those annual conferences. Yeah, with that having said, thank you very much. I'm through here and I'm very happy to discuss those findings with you now.